Hello students, today we are going to discuss JAM 2021 differential equation solution. In this particular section, in differential equation, this year 7 questions have been asked and they are moderate to easy questions. They are not very difficult as such. So all these questions you could have made by whatever existing knowledge of differential equation you had. A few questions like one or two require you to go beyond whatever has been asked in the examination, like you need to know existence and uniqueness theorem. But I believe that at least now the way the JAM has increased its level, I will recommend you that you should now for JAM 2022, you should also take in consideration existence and uniqueness theorem. Okay. So let us begin with the question number 1. And also to add, IISc has released its answer keys. So kindly go through that answer keys and see if you are in the contention of getting into IITs or not. Around 50 numbers will be suffice, around 45 to 50 from my side. I believe that you shall get an IIT, but still 50 will be a safe score. If you are getting below it, then start preparing for other MSc entrances for which we are running the batches. Okay. So question number 1 that has appeared in the examination, like whatever paper I have from IISc website, you can pick that paper. I'm going by that reference. Okay. So question number 1. So question that has been asked is the number of differential functions from 0, 1 from 0, infinity having continuous derivative on 0, 1 having continuous derivative on 0, 1 0, 1 satisfying y dash t is equals to yt raised to power alpha, yt raised to power alpha where t belongs to 0, 1, where t belongs to 0, 1 and y0 is given to be equal to 0 and y0 is given to be equal to 0. So there are several options that has been asked in the examination. The answer to this question should be infinitely many solutions. Okay. In the theory of differential equation, in order that your solution exists and is unique, there are some sufficient conditions. Okay, so there are sufficient conditions named as existence and uniqueness theorems. Okay, so this particular topic is not in your syllabus, but let me go through that particular topic. But rather, you will feel that at the end you will have to think upon the solution, because these conditions are only sufficient conditions and not necessary. But let me start with where the genesis of the problem lies. So existence and uniqueness theorem. Okay, so if I'm giving you an IVP, say y dash is equal to f of xy, such that y of x naught is equal to y naught. For this particular IVP, in order to have a single solution, a unique solution, what are the conditions? The first condition is let fxy and del f upon del y be continuous functions of x and y on a rectangle R given by mod of x minus x naught less than a and mod of y minus y naught less than b. Then if fxy is bound, fxy and del f upon del y is bounded, that is, if they are continuous functions and also bounded, then IVP has one and only one solution. then the IVP has one and only one solution. That is, it has a unique solution. So in order to have an existent solution, you need that your fxy should be continuous and bounded. And in order to have a unique solution, you should have your del f upon del y continuous and bounded. So if del f upon del y is continuous and bounded, and if fxy is continuous and bounded, then you will have a unique solution. In certain texts, you will find, in certain texts, what in general, you'll find that this particular condition of boundedness of del f upon del y is replaced by a weaker condition called as a Lipschitz condition using the extended mean value theorem in two variables. So for example, if your function is Lipschitz continuous, that is, if there exists y1 and y2 such that f of x1 comma y2 minus f of x comma y1 minus f of x comma y2 is less than, then the solution is, then f is said to be Lipschitz continuous. Okay, so it is said to be Lipschitz continuous, and all the more this L is said to be Lipschitz constant. So in order to have a existent and unique solution, that is, if your solution exists and is unique, what do you need? You need your fxy to be bounded and continuous, and you need your del f upon del y to be continuous as well as bounded. In most of the textbooks, you'll also find a Lipschitz condition, that is a weaker condition to the continuity and boundedness of del f upon del y. So it is replaced by del f upon del y being bounded is being replaced by a weaker condition called as Lipschitz continuity. So if you have these conditions, then you have unique solution to the IVP. Now note that these conditions are only sufficient. That is, if they fail, you cannot say anything about the uniqueness and existence. It might be possible that solution is unique, it might be possible that solution is not unique, so nothing can be said. In general, let us evaluate this particular problem from not this slide, but from another way around. Why? Because see, if you see, so question that has been given in your examination is y dash is equal to y ki power alpha, where alpha lies between 0 and 1. See, if you consider any rectangle enclosing the initial conditions like x minus 0 less than a and y minus 0 less than b, because the initial conditions given to you happen to be y0 equal to 0, so your x0 and y0 happen to be 0 and 0. So if you take the rectangle, this arbitrary rectangle, so you can clearly see that this particular y ki power alpha is continuous as well as bounded, continuous plus bounded. But what about the del f upon del y? So clearly, if you see that del f upon del y will be equals to alpha y ki power alpha minus 1, and since alpha lies between 0 and 1, so this particular quantity will get unbounded as y tends to 0. And if you consider 0 comma 0, any rectangle enclosing this particular point 0 comma 0, that is x minus 0 less than a and y minus 0 less than b, will give you this particular rectangle. Any rectangle enclosing 0 comma 0 will obviously contain this particular line, and this particular line is y is equal to 0. So therefore del f upon del y will be unbounded as well as not defined at y equal to 0, and as y tends to 0, this particular thing will become unbounded. So therefore your existence and uniqueness theorem fails here. Although the solution will be existent since your fxy is continuous as well as bounded, but the del f upon del y, the weaker condition, that is a Lipschitz continuity also, or del f upon del y is unbounded. So therefore you will not have any idea about the existence and uniqueness of the solution from here. So what you need to do, let us start with something different. So let us start with assuming what can be the possible solutions to this particular problem. So y dash t is given to be yt raised to power alpha, where alpha lies between 0 and 1. So I'm telling कि इसको कैसे करना होगा, how will you be able to do it? So first solution, you can clearly see that yt is equal to 0 for all x belongs to R, and in fact for all x belongs to 0, 1 precisely is a solution. So clearly this particular thing is a solution, no doubt. Another solution that you can do is y dash t divided by y ki power alpha is equals to 1. So clearly dy upon y ki power alpha is equal to dt. Now you can integrate it on both sides. What you will get? You will get 1 upon 1 minus alpha, y ki power 1 minus alpha is equal to t plus some constant of integration. and replacing the original equation, that is y at 0 gives you 0, that implies c is equal to 0. That will give you y 1 minus alpha is equal to 1 minus alpha times t, and y as a function of t can be written as 1 minus alpha raised to t raised to power 1 upon 1 minus of alpha. So clearly this happens to be another solution. So till now you have two solutions. Okay, so till now you have two solutions. Okay, so exactly one solution is rejected because 0 is the solution and this particular thing is the solution. Exactly 2 for now it is right. Now finite but more than 2, and then there are infinitely many solutions. So see, I can extend this function. So this particular function can be extended to a differentiable function given by extended to a differentiable function given by now see, I'm assuming that y belongs to r plus, there is a positive real number and this is arbitrarily chosen. So let gamma be a arbitrarily chosen positive real number, and let us extend this solution. Let us extend this solution. So let me write a solution of this form: yt is equals to 1 minus alpha t minus gamma raised to power 1 upon 1 minus alpha if t is greater than equals to alpha, and if t is less than alpha, then it is equals to 0. So clearly you can see this particular thing is continuous over t equals to gamma, and for otherwise round, this is a constant function, this is continuous as well. At t equals to gamma, it is continuous solution. So no issues with continuity. Differentiable, no issues with differentiability. Let us assume that this be the solution of the given differential equation. Let us see if it happens to be a solution or not. So if t is less than gamma, then nothing to prove because at t less than gamma you have 0. So derivative of 0 is 0, and by t raised to power alpha, 0 raised to power alpha is 0, no issues. What if t is greater than equal to gamma? So if t is greater than equal to gamma, then dy by dt will be equals to 1 upon 1 minus alpha, 1 minus alpha t minus gamma raised to power 1 minus alpha minus 1. So you'll get alpha divided by 1 minus alpha times 1 minus alpha, because t is multiplied with 1 minus alpha, so this gets cancelled. And what it happens to be, it happens to be by t this happens to be 1 minus alpha raised to power alpha. So what does it happen to be? It happens to be y raised to power alpha. So dy by dt is equals to y k power alpha. So therefore this particular solution also satisfies the given differential equation. And since gamma belongs to r, so as many as gamma are there, as many as solution will be there. So how many numbers of gamma can be there? So there are infinitely many, in fact uncountably many positive real numbers. So for every uncountable, for every positive real number you have a solution. So therefore as many as gamma are there, as many solutions are there. So therefore there will be infinitely many solutions to this problem. So answer will be D, infinitely many solutions. So note this D I am marking by the answer keys and the questions of IISc paper that as IISc is uploaded. So kindly download those papers and find the answer keys and questions accordingly. Okay, so let us move to another question, that is the question number 2. Now this particular question happens to be a question from differential equation, but at the end I'll say that this particular question is more on the analytical side, so probably you can consider it as a real analysis question also, but let us see how you will do it. So question number 2, given that px is positive and continuous function such that y double dash x plus px into y dash minus y is given to be equal to 0. So this is a second order linear differential equation and an homogeneous kind, and suppose that there exists two real numbers such that ya is equal to yb, then what can be said about yx, whether yx will be positive, whether yx will be negative, whether yx will change sign, or whether yx will be trivially 0 or identically 0 or entire interval. Now this is a very beautiful question. Let us start. Okay, so let if possible it is not 0, let if possible yx is not equal to 0. So what will happen? Say this is a kind of graph that you can expect, just stating, just don't think that this is the graph of the function, and just stating if it is not equal to 0, that implies it will be positive for some interval, negative for some interval. That is how I will be thinking. Okay, so let if possible it is positive, and let it achieve a maxima and a local minima. Now what you will say that why will it exist a maxima and minima? Because see, at the endpoints it is 0, and if at all it is being positive or negative in this particular interval, then obviously maxima and minima will be that positive and that negative. Also note that this particular thing is been defined on a compact interval, that is a comma b. This question has been defined, and the question, although options will be defined on a compact set, that is a comma b. So if there is a compact set, continuous image of a compact set is compact, or otherwise from extreme value theorem you know that if y is a continuous function and it is defined over a compact interval or compact set, or I may say that a bounded set, then it attains its bounds, that is it will attain supremum as well as infimum, and obviously at endpoints it is 0, and if at all it is non-zero in between, then it may be positive or negative. So therefore existence of maxima and minima, if at all it is possible, then it will be positive or negative in some particular interval. This is what I'm assuming. So let me assume that it has a positive maxima or a negative minima. Okay, so this is how I'll start. Okay, this is how I'll start. So consider y to be defined from interval I to R, where I is given by a comma b. Now clearly yx, since it is a second order differential equation, has been defined, so yx has to be continuous as well as differentiable. Only then you have first order derivative existent, and only if first order derivative is continuous as well as differentiable, only then in that case you have the second order differential equation being defined. So you have second order derivative, you have first order derivative, so it implies that yx has to be a continuous function. So yx will attain its bounds, will attain bounds. So let if possible yx be non-zero. That implies, without loss of generality, let us assume that capital M and small m be two such numbers where y holds maximum and minimum respectively. So let us assume that there are two such numbers where m and capital M obviously belong to closed interval a comma p. Okay, closed interval a comma p. Okay guys, so this is one way. Okay, so now if ym is positive, so if you have a maxima, let us assume that this particular function has a positive maximum, that is ym is greater than 0. So if ym is greater than 0, also m is the point of maximum. Since m is a point of maximum, it implies y dash m has to be equal to 0, the necessary and sufficient condition for the existence of extremum if a function has the derivative. Okay? So y dash m will be equal to 0. It implies, since m is a point of maximum, it implies y double dash m has to be less than 0. Okay? Has to be less than 0. So if at all it is the case, it implies your y dash m plus pm into y dash m minus ym, so your y dash m plus pm into y dash m minus ym. See, so your y double dash m will be negative, your pm into y dash m, this will be, I think, again negative, this will be again 0, and ym will be negative. So it implies, so this contradicts the given differential equation. This contradicts the given differential equation. This contradicts the given differential equation. Clearly, the differential equation states that for all y belongs to a comma b, the y double dash x plus px into y dash minus y is supposed to be equal to 0. But contrary, If you have a maximum, positive maximum, then y m is positive, y double dash m will be negative. In that particular case, y double dash m will be strictly less than 0. This is entirely 0, and y m, since it is a positive quantity, so this will be negative overall. So overall it will be a negative thing, which contradicts the definition of the function y or the given differential equation. And similarly, suppose that suppose that ym is a negative minimum. So let us assume that ym is a negative minimum. So if at all it has a negative minimum, that implies ym will be less than 0 and y double dash m will be greater than 0. If it is possible, then it implies that your y double dash m plus pm into y dash m minus ym will be greater than 0, because this is 0, this will be 0. It implies this entire thing will be greater than 0. Therefore, it contradicts the definition of the given differential equation or y. Okay? Therefore, it implies yx is equal to 0 for all x belongs to a comma b. Okay, so yx has to be equal to 0 for all x belongs to a comma b. I hope it is clear. So therefore yx has to be identically 0. There may be another way of doing it. Let us see another way of doing it. Alternative, but now this is a kind of scratchy thing that I'm writing. So probably it may have some kind of errors, flaws that you are supposed to see. If this works fine, if it does not work, then the earlier proof that I've given is flawless. I believe this is flawless. Let us see another way of doing things. So what has been given is that your px is greater than 0. So if your px is greater than 0, that implies y double dash x plus px into y dash x minus yx is given to be equal to 0. It implies, since px is greater than 0, it implies yx minus y double dash x divided by y dash x has to be greater than 0. Okay? So this is what I've done from putting these things around. So if y dash x is not equal to 0, then what I can write, I can simply write that your y dash x into yx minus y dash x times y double dash x is greater than 0. So this is greater than 0, integrating, what you will get? So what you will get on integration? Okay, so if you integrate it all over again, so you won't get much to know, but probably you will see one thing, that if you integrate it from okay, so what you can do probably is you can write it as d of y dash x minus d of yx minus d of y dash x, and this is supposed to be greater than 0. And if you integrate it, you will get y square x divided by 2 minus y dash x ka whole square, y dash x ka whole square divided by 2, and is greater than 0. So if you integrate it over both sides, what you will get, you integrate it from, say, some x naught to some arbitrary value. Say you integrate it from, say, 0 to x naught, okay, and let x naught be any arbitrary real number. So this is a kind of scratchy proof that I'm giving. Probably in examination you could have figured it out from somewhere from here also, but it's not an absolute proof, just giving a sketch of a proof. Okay, so don't think that it is an absolute proof. So obviously you will get y of x naught, y square x naught minus so what you could have figured out from here is possibly this way. इससे यहाँ से इतना पता चल सकता था कि y square x naught, and if you can generalize it, then y square x minus y dash x का whole square will be greater than 0. So you could have made two cases from here. One case can be yx minus y dash x, and one case can be yx plus y dash x, because if you multiply these two, you will get this, So if both are positive and if both are negative, this can be the case. If you multiply with e to the power minus x, what you will get? By x minus. So possibly you can leave it alone, like this is not going to work, so you can leave it. I believe that whatever you have done is better, so leave it, because at the end, if you multiply with e to the power minus x from here, you will get, so let me try, if it works out fine. So it is d e to the power minus yx. I think y dash x is already negative, so what you can do possibly is, you can keep this way, so this is less than 0. Okay, that implies d of see, if you multiply with negative, that gives you this, so it implies e to the power minus x into yx is a decreasing function, is decreasing function, is a decreasing function. Now if at all it is a decreasing function, then e to the power minus x into yx. Okay, now see, if x belongs to a comma b, if x belongs to a comma b, then e to the power minus x into yx will lie between e to the power minus a into y of a, and from here it will be equals to e to the power minus b, sorry, e to the power minus b, and here you will find y of b, and here e to the power minus a, and here you get e to the power minus a into y of a. Now y of a is given to be 0, this is given to be 0, but this gives you a contradiction that yx cannot be a decreasing function. See why? It cannot be strictly decreasing, because here also it is given to be 0, here also it is given to be 0. So obviously yx cannot be a decreasing function over this particular interval. See, if you are taking a and b, then this is what you are getting. So there is a hint that yx cannot be strictly decreasing. And similarly, you can find from here, if you multiply it with e to the power x, so what you will get, y plus y dash x greater than 0. It implies d of e to the power x into yx has to be greater than 0. It implies e to the power x into yx is strictly increasing. And if it is strictly increasing, then for all x belongs to closed interval a comma b, what you shall get, you will get e to the power a into ya. And here you will find e to the power b into yb. So ultimately, again, e to the power x will lie between 0 and 0. So what gives you the answer? Like, it cannot be strictly increasing as well. So if it is increasing, since a is greater than b, strictly increasing. If it is strictly increasing, then the value at a must be less than value at b. But here you will get in that on both sides it is bounded by 0. So obviously it cannot be strictly increasing, nor it can be strictly decreasing. And if function is differentiable, and if function is differentiable and increasing, then y dash x is supposed to be greater than 0. It is not the other way around, because there is a question in this year's paper also. So if function is increasing and function is differentiable, then y dash x is supposed to be greater than 0. If y dash x is greater than 0, does not imply your function is increasing. So if I am stating that your function is increasing, then function is not strictly increasing, not strictly decreasing. It implies y dash x to be equal to 0. It implies yx has to be constant, and yx is to be constant, and at 2 points a and b, yx is given to be 0. It implies yx has to be trivially 0. No, kindly note that this is only a sketch of a proof that you could have done in your examination. It has got no certainty. Probably while doing up things here, I have done that x naught is an arbitrary number. Why I have stated this? Because if I'm going to integrate it all over, then you're supposed to find a constant also. So in general, this particular thing is only a sketch that you could have done in your examination. Probably you could have got a hint by doing this particular thing, but this happens to be a more appropriate proof. Okay, there can be other way around also. You can assume px to be some values. You can put px to be equal to 1 or 2 or something of that sort also you could have done. That also will serve your purpose probably. I don't know much about it, but you could have done like, say, px equals to 2, px equal to 1, and you could have easily made this particular question also. So from my side, if you're asking this question is a difficulty level, this is only a medium level question that you could have easily done in your examination. Okay. So most possibly this should be the solution of this particular equation. This I have achieved using contradiction. Okay. So what I have done in this particular question, I have assumed that your solution is your function yx if it is not trivially zero, then it is supposed to be positive or negative somewhere in the interval. So if it is positive, say if it is positive, then it will achieve some maximum value, while it will achieve some maximum value because we already know that it is defined on a compact set A comma B. So if there is a compact set, then range set should be bounded, and if range set is bounded, that is, it will achieve some maxima as well as minima. So for example, let's say if it achieves some maxima, say positive, and let's say it assumes some negative value, and let it be a minima. Why I'm saying this? This is the most general case that can be possible. So if yx is not equal to 0, there can be two possibilities, that it is either positive in this interval somewhere and it is negative somewhere. So let us assume that it happens to have a positive maxima and it happens to have a negative minima. So if it happens to have a positive maxima somewhere at some interior point C, then the condition of extremum, necessary condition of extremum dictates that f dash C has to be 0 at that, y dash C is supposed to be 0 at that particular point. So what we will get at the end, so this particular thing gets negated, so therefore it implies yx has to be equal to 0. Okay. So, and all the more by differential equation, we already know that let C be any point between A comma B. So therefore yc will be equals to 0 and y dash c is also equals to 0. So by uniqueness of solutions, by uniqueness conditions, what we'll get yx is equals to 0. Now why I'm stating uniqueness? Because given differential equation is of second order and you have boundary conditions being specified like yc is equal to 0 and y dash is equal to 0, therefore your solution has to be unique. Therefore yx trivially 0 is the only solution to this particular problem. The second way of doing it is kind of sketchy. There can be a flaw there, but this is another way that you could have attempted in your examination, I'm saying. So don't worry, this might appear to you a little bit sketchy, but this would have worked in your examination if you would have not thought to say, probably you would have gone through this thing, because see, if you have multiplied it with e to the power x here minus x and you have integrated, so you can clearly see this, that d by dx of e to the power minus x by x is strictly less than 0. Strictly less than 0, by which I mean that this is a decreasing function. But if it is a strictly decreasing function, then a and b, at by b the function is supposed to have a strictly decreasing, then by at b you will have you will have a minimum there, and at a you are supposed to have a maximum value. But it happens that this is entirely bounded by 0 on both ends. Therefore it will not be strictly increasing, neither it will be strictly decreasing. So therefore it is supposed to be y dash is equal to 0. Now why I have assumed that y dash is not equal to 0? Because clearly you can see that this is the case. So this is why I'm doing, because I have isolated px, isolated the other terms from px, so therefore y dash happens to be on denominator side. So therefore I am writing y dash x is not equal to 0. Y dash x in all rights can be equal to 0 as well. So if y dash x is not equal to 0, it's supposedly be equal to 0. That implies that yx has to be constant, and at 2 points ya and yb it is given to be 0. That implies yx is equals to 0. That implies yx, that is the trivial solution, is the only solution to given differential equations. I hope you would have got this particular thing. Okay, so let us move to question number 12. Let us move to question number 12. So let us move to question number 12. It is given in your this IISc papers that have been downloaded. Okay, so this particular question involves the concept of the Cauchy-Euler condition, Cauchy-Euler equations, and I hope that when you have had studied for your IIT-JAM examination, you would have had enough exposure to Cauchy-Euler equation. This is a reasonably easy question. I think you could have easily done it. So all in all, if I say, only barring the first question, that particular first question was based on existence and uniqueness, and at the end it was not even applied there. So possibly when you are taught existence and uniqueness, you are taught with differential equations like dy by dt is equals to y to the power half, and it has also occurred in your JAM examination in previous year. So possibly I thought you would have had an experience to this particular problem. If you would have had an experience to this particular problem, you could have easily made it. But if you had no experience, then this happens to be a difficult question. Okay, and this happens to be a mediumly difficult question. It is not even difficult, it's moderate question, if you would have thought. Okay, so this is a moderate question. Now, next question hai, this is an easy question. Why do I say it's an easy question? Because this was based on Cauchy-Euler equation, which happens to be part of your syllabus. Okay, so question number 12, an easy question, y1 plus x, y double dash x. So I'm writing it in a modified form. the one that is not given in your examination, but that one that you can do by simply multiplying 1 plus x on entire side, both sides. Given that y0 is equals to 1 and y dash 0 is equal to 0. So you are supplied with initial boundary conditions. Now what is the concept involved? So concept involved is Cauchy-Euler equation. So this is a moderately, not moderate even, it's an easy question. Okay, so how to do this particular problem? You just replace 1 plus x by e to the power z. So if you replace this particular thing, that is if you use this particular transformation, what do you get? You reduce the variable, reduce this variable coefficient equation. This variable coefficient equation gets reduced to a equation of constant coefficients. So this particular equation becomes a constant coefficient equation. So what do you get? So 1 plus x ka whole square d square y gets reduced to d bar into d bar minus 1 into y. ठीक है, d bar into d bar minus 1 into y, and 1 plus x dy happens to be d bar y. So what you will get? You will get simply d bar the whole square minus d bar y plus d bar y minus 1 minus y is equal to 0. So what you will get? You will get d bar whole square minus 1 times y is equal to 0. That implies y as a function of z. You will get c1 e की power z plus c2 e की power minus z. और z को आप कैसे replace कर सकते हो? You can replace z by ln of 1 plus x. So what you will get? Cy as a function of x. You will get c1 1 plus x plus c2 divided by 1 plus x. And if you use initial condition y0 is equal to I think 1 and y dash 0 is equal to 0, you will get c1 is equal to c2 and it is equals to half. So this is your homework that you can do. So yx you will get as 1 upon 2 1 plus x in plus 1 upon 1 plus x. So जो options पूछे गए exam में, according to that I'm giving you the answer. If x is given between -1 से लेकर infinity, it has been asked that what will be the range of yx. So first question is the option number C. Let me do the option number C. So if x lies between -1 and infinity, that implies x plus 1 will be greater than 0. So now you are here, you can apply your arithmetic mean greater than equal to geometric mean. So if a plus 1 upon a and a is greater than 0, then it is always greater than equal to 2. This is clearly arithmetic mean greater than equal to geometric mean inequality. So using this particular thing, you can do this particular problem. So if I'm supposed to use that thing, then x plus 1 will be greater 1 upon 1 plus x will divided by 2 will be greater than equal to x plus 1 into 1 plus x, and equality exists only if x plus 1 is equal to 1 plus x. That implies it only exists if x plus 1 ka whole square happens to be equal to 1. That implies x plus 1 happens to be plus minus 1. That implies x happens to be either 0 or -2. So neither -2 is contained in -1 comma infinity, neither, but x equal to 0 happens to be contained in this particular interval. So I can write that x plus 1 plus x is greater than equal to x into 1 plus x raised to power 1 by 2, and therefore it implies x plus 1 upon 1 plus x is greater than equal to 2 for all x belongs to -1 comma infinity, using arithmetic mean greater than equal to geometric mean, by which I can write that your yx is greater than equal to 1 for all x belongs to -1 comma infinity. So therefore, the range of yx is greater than equal to 1, nor greater than equal to 2. So it has been asked in your examination. So C does not happen to me the right answer. Now, regards option number A. So option number A, it is given that your yx is bounded on 0 comma infinity, which is not the case, because clearly you can see that limit x tends to infinity, x plus 1 is equals to plus infinity. So therefore there is one component, that is x plus 1 blows away. So therefore yx is not bounded on 0 comma infinity, neither it is bounded on nor bounded on -1 comma 0. So why it is not bounded on -1 comma 0? Because limit x tends to -1, 1 upon 1 plus x goes towards plus infinity. So neither this is the answer nor this is the answer. Now what happens is the last option. So exam में आप चाहते थे यहीं पे खत्म कर सकते थे, but many people would have found that how to find minima out of this. So probably you would have differentiated. No, don't differentiate it. Since function is given to be differentiable and at 0 you have y dash 0 equal to 0, that itself implies that your 0 is the point of minima, point of extremum. So this is your point of extremum. Now let us see that this particular point of extremum happens to be a point of minima or maxima. How to do it? Simply replace 0 in the given differential equation. If you clearly replace this particular thing in the given differential equation, what do you get? That is, at x equal to 0, what you will get? At x equal to 0, if you replace all these things, what you will get? P0 into y dash 0 minus y0 is equal to 0. So what you will get? You will get y double dash 0 equals to 1, because y0 is equals to what? Y0 is given to be equals to 1. So therefore at 0, your second derivative is positive. It implies 0 is the point of minima. So from my side, the answer will be, from my side, because now since IIC has released the answer, so this happens to be your answer. That is 0 is the point of minima. So yx will attain its minimum at point x equal to 0. This is your answer. So question number 12, the answer will be D. Okay. Now next question that has been asked is from MSQ. Again, it is an easy question. So you could have easily attempted it. No worries. You could have easily attempted it, I will say. Okay. Oh, no, sorry. There's a question in orthogonal trajectories also. This is question number 19. So question number 19, it is again based on orthogonal trajectories. So it has been quite a while that now questions from last a few years, if you would have seen that questions are coming from orthogonal trajectories. So it is an easy question, again, easy question. Let us see how. So these are the questions that you could have done and easily scored around 50 numbers in your examination, and that would have easily made you sail through your cutoff, and most possibly even your IITs would have been there. So थोड़ा सा skillful होके if you would have attempted the paper, it was an easy paper, not easy paper, it was a difficult paper, but if you would have attempted in right direction without even panicking, you would have easily made 50 numbers out of this particular paper, that I can say. Okay, so given question is x square minus y square is equal to ky, and you're supposed to find the orthogonal trajectory to this particular family of curves. So as you would have seen, then whenever you are supposed to find orthogonal trajectories, what is the standard methodology? Is to replace dy by dx by minus dx by dy. And why it is done? Because you simply know that whenever you have orthogonal trajectories, the product of their slopes is supposed to be equals to -1. So if one slope is given to be dy by dx, the orthogonal trajectory to a given family of curve is supposed to have a slope of minus dx by dy. This is a standard protocol that we follow. I'm not going into deep of it, but I believe that this is something that you would have considered, you would have revised you would have done in your things. So in order to find orthogonal trajectories, what do? You replace dy by dx by minus dx by dy. So I'm not getting into how do you do these things, but certainly I believe that you would have done this particular thing. Now what to do? You simply differentiate it. So what will get? 2x minus 2x into y into y1 is equal to k into y1. So this is your equation number 1 and this is your equation number 2. इसमें करना क्या? What you are supposed to do, you have to replace y1 by minus 1 upon y1. So you're supposed to replace y1 by minus 1 by y1. So minus 2x plus 2y divided by y1 is equals to minus k divided by y1. So at the end, what you're getting 2x into y1 plus 2y is equals to minus k. And if you can replace k by, from this particular equation, from 1, you can replace k. From 1, eliminate k. Because k is one point that you are not able to find how to go about it, because in all the options you are not having k. So let us eliminate k. So how to kill k? You can simply write k to be equals to 2x dy upon dx plus 2y is equal to y square minus x square divided by y. So what you are getting this. So what you are getting, 2xy dy plus 2y dx is equals to y square minus x square. So let me let me multiply it all over again first by y, so that you'll get just give me a minute. Okay, so let us multiply it all over again by y. So what you are going to get, 2xy dy upon dx plus 2y square is equal to y square minus x square. And what you will get simply 2xy dy plus, you replace all these things, you will get x square plus y square and here you are getting dx equals to 0. So this is clearly an exact differential equation if you consider it to be equal to m, and if you consider it equal to be n, then mx happens to be 2x and ny happens to be 2x. So clearly this equation is in exact form. So how do you do the questions in exact form? You simply integrate m dx, keeping y constant, okay, and you integrate n dy of all those terms which are free from x. This is a shortcut formula that you do. So what you will get from m dx, so keeping y constant, m is x square plus y square, so you will clearly get x cubed by 3 plus xy square, and free from x there are no terms, so therefore this is 0, so you will get c1. So what you will get? You will get x cube plus 3xy square is some constant k. Now exam में दिया क्या हुआ है आपको? You are given that you're given that the curve passes through point 1, 1. Since through point 1, 1, it implies k you will get equals to 4. So you replace 1 by 1, so you get k equal to 4. That implies your orthogonal trajectory happens to be 3x cube plus x cube plus 3x square y, 3xy square is equal to 4. So I believe this was your option number 1 in your paper. So this is the answer to your given differential orthogonal trajectory question. So this was question number 19 in your paper. So this is again an easy question. You would have easily made it. Now coming to a little stiff question. This was an easy question. Now there's a stiff question. I can say not exactly stiff, but yes, a little bit lengthy question, but it was again an easy question. You could have easily made it. So again, to an easy question. This is question number 25 in your paper. Given that there was a differential equation y double dash x is equal to e2 plus e to power minus modulus of x, and given that your y dash 0 was equal to 0 and y0 was given to be equal to 1. y0 was given to be equal to 1. So your y0 was given to be equal to 1. So how to go about this particular problem? See, a little bit of everything probably you can do. The best way is to do it like a differential equation way. So differential equation के तरीके से अगर करते हैं, so how you would have attempted this particular problem in examination. So if it is y double dash x is equals to 2 plus e to power minus x whenever x is greater than equal to 0, and whenever x is less than 0, then it is 2 plus e to power of x. Clearly, so y double dash x ये आएगा. So now this is a differential function, this is a differential function, and clearly at x equal to 0, these happen to be a continuous function as well, and as well as differential function. You can just check it. Okay, so y dash x happens to be 2x minus e to power minus x plus c1 and 2x plus e to power x plus c2 for all x less than 0 and for all x greater than equal to 0. By using the initial conditions, what you will find that c1 happens to be minus 1 and c2 happens to be c1 happens to be minus 1 and c2 happens to be minus 3. So this is, I think you can do it on your own. देखिए करना क्या है, आप y dash 0 को equal to 0 place कीजिए, and since left hand and right hand derivatives must be equal, then only then your function's derivative will be defined, that the second order derivative will be defined only when your first derivative is differentiable, that is your first hand derivative, first derivative ka left hand and right hand derivative at any point on the domain must be equal to 0. So therefore y dash 0 plus should be equal to y dash 0 minus. So what you will get c2 equals to minus 3. So this is something that you can easily find. So I'm writing as it is the values that are found. Please, if there is some error, do tell me in the comment section. We shall resolve. Okay. So this is what you're getting. Now, if you're finding yx, so yx आपको क्या मिलेगा? You'll find it as x square plus e to power minus x plus c3, and here you'll find c4 minus 3x. You'll find here you'll get e to power x here and x square here for all x less than 0 and for all x greater than equal to 0. Okay. अब देखिए आपको क्या पता करना था? अच्छा, okay. Now again, if you apply y0 equals to the initial condition that is given y0 equals to 1. If you apply these conditions, what you are supposed to get, since yx is continuous, so for 0 plus and 0 minus you will have the same way. So what you can do, you can simply find that your c3 happens to be equals to minus y0 is given to be equal to 1. Sorry, y0 is given to be equals to minus 1. Sorry. So y0 is given to be equals to minus 1. So if y0 is given to be equals to minus 1, then what you are getting, you'll be getting c3 as minus 2 and c4 as also minus 2. Okay, so this is something that you can verify on your own. I'm leaving it up to you. So you're getting y square x as this particular thing. Okay. Now, there can be two methods to it. What you can do, आप क्या कर सकते हैं, yx equal to 0 चेक कर सकते हैं. So let us check yx equal to 0. पहले x greater than equal to 0 के लिए चेक करते हैं. So for x greater than equal to 0, let us see. So what you will get x square plus x minus 2 plus e की power minus x equal to 0. So अगर इसको सही मानते हैं तो what you will get, e की power minus x will be equals to minus of x square plus x minus 2. So यहाँ से सोचें तो ये x स्क्वायर प्लस x माइनस 2 ये नेगेटिव में. So अगर थोड़ा सा इसका ग्राफ लाने की कोशिश करें तो इसके रूट्स दिख रहे हैं आपको, साफ दिख रहे होंगे. It will be some -1 and 2. So it will be an inverted parabola. Okay. So this will be an inverted parabola. And if you are drawing the graph of e की power minus x, so this will be your e की power minus x. So clearly at this particular point and this particular point you will have two solutions. But what are we seeing? We are seeing at x greater than equal to 0. So there is only one positive solution. So exactly one positive solution here. Okay. And another one is yx equal to 0 for all x less than 0 if you are saying. So what does it imply? It imply e की power x is equal to minus of x square minus 3x minus 2. Clearly this particular discriminant is coming to be equals to 9 plus 8, that is 17. So greater than 0, it implies there will be two roots alpha and beta. One will be negative, another will be positive. You can clearly see that it is negative and inverted parabola that I'm making. And if you clearly make a graph of e की power x, so on negative side you will find one root and on positive side you will find one root. That implies you have exactly one negative solution. Exactly one negative solution. So in total, yx equal to 0 will have exactly two roots. yx equal to 0 will have exactly two roots. अगर आपको ऐसे नहीं आ रहा होता तो एक और तरीके से मैं करके बताता हूँ. That is also easy. But for that also you would have had to do up till now. यहाँ तक तो आपको तब भी करना ही था. देखिए कैसे, yx आपको पता ही है. Okay. Now clearly see that your y0 is given to be equals to minus 1. y0 is given to be equals to minus 1. And if you see tends to infinity, this will go to 0. This will go to minus infinity, but the more dominating term will be x square in comparison to minus x. Whenever x tends to plus infinity, x square will be dominant over minus x. That is how I can do in very small, in this particular short interval time, I can explain you that x square will be dominating over x. Clearly you can see that as x tends to large values, x square will be way greater than x. So clearly as x tends to infinity, this goes to 0, this will be not as large as x square. So obviously this particular term will go towards infinity. Whenever x tends to minus infinity, this will go towards 0, this will go towards plus infinity, and this will also go towards plus infinity. So in totality I can write limit x tends to infinity, yx will be equal to plus infinity, and limit x tends to minus infinity, again yx is equal to plus infinity. So clearly on negative infinity you are getting towards plus infinity, and on positive infinity again you are getting towards plus infinity. At y0 you are getting a negative value. It implies there exists, by intermediate value theorem, see it is going to plus infinity, it implies there exists some m greater than 0 such that yx will be greater than m for all x greater than k, where k is some positive number, and there exists some n greater than 0 such that yx is greater than n for all x less than some minus of k. So from minus of k, yx will be greater than m, and for all x greater than k, yx is greater than m. So yx is greater than some positive quantity. This is the definition of limit diverging at infinity and limit diverging at infinity as x tends to minus infinity. So this is the definition there. So by intermediate value property, there exists at least one positive root, and there exists at least one negative root. Okay. Now, if you see that your y dash x was given to be equals to what? It was given to be equals to 2 e की power minus mod x, and it is obviously greater than 0 for all x belongs to R. It implies y dash x is greater than 0. It implies yx is increasing function, and when yx is an increasing function, it implies yx is monotone, and when yx is a monotone function, when yx is, or otherwise I can write you a theorem that I'm giving you. See, if y dash x is greater than 0, it implies y dash x is not equal to 0. Whenever your y dash x is not equal to 0, it implies yx has at most one real root. Now how does that happen? See, अगर आपके पास y dash x non-zero आ रहा है, then y dash x as at most one real root. This I'll prove later, but for now you are just understand it. Because अगर y dash x greater than 0 दे रखा है, इसका मतलब क्या हुआ? It implies your y dash x is increasing. अगर y dash x increasing है, now clearly see that for all x greater than 0, y dash x will be greater than y dash 0. y dash 0 कैसा दे रखा है? 0. इसका मतलब y dash x क्या होगा? 0 से बड़ा. And for all x less than 0, y dash x will be less than 0. इसका मतलब y dash x in short will be non-zero for all x greater than 0, and it will be non-zero for all x less than 0. और मैं कह रहा हूँ जब भी y dash x non-zero आएगा तो yx has at most one real root. So at most one real root and at least one real root. It implies exactly one real root. It implies yx has exactly two real roots. अब ये क्या हुआ मैं बताता हूँ. Exactly two real roots. देखिए ऐसा क्यों होता है कि y dash x जब नॉन जीरो तो yx has at most one real root. Let us see this particular statement, but first understand for all x greater than 0 y dash x will be positive. That implies y dash x will be non-zero, and for all x less than 0 y dash x will be less than 0. That implies y dash x will be non-zero. So whenever you have y dash x non-zero, as a consequence of Rolle's theorem, y dash x has at most one real zero. So at most and at least it implies only one real root. So you have one real root on the positive side, one real root on the negative side. It implies exactly two real roots. अब इसका क्या मतलब होता है देखिए. Y dash x equal to 0, it non-zero, it implies yx has at most one real root. At most मतलब समझ रहे हो? या तो एक रूट होगी या फिर रूट नहीं होगी. कैसे? देखिए ऐसे. Let if possible, मान लेते हैं let if possible alpha not equals to beta be two real roots. मान लेते हैं दो real root है इसकी alpha और beta be two real roots. It implies y alpha and y beta will be equal to 0. But by Rolle's theorem, then there will exist some gamma belongs to alpha comma beta such that y dash gamma will be equals to 0. That clearly is a contradiction. क्योंकि हम क्या कह रहे हैं कि y dash x कैसा है नॉन जीरो. अगर इसके पास दो रूट्स हुई तो पक्की सी बात है एक ने एक पॉइंट जरूर गामा मिलना चाहिए by Rolle's theorem such that y dash gamma is equal to 0. Therefore we arrive at a contradiction. So therefore it can not have two roots. It can have only less than two roots. That is yx can have at most one real root. आई होप ये चीज समझ में आई होगी. ठीक है जी. तो द क्वेश्चन भी अगेन एनालिटिकल अप्रोच था. सो ये क्वेश्चन का आंसर थोड़ा सा डिफिकल्ट था, बट आई बिलीव यू वुड हैव डन इट, नो इश्यूज. सो फॉर दिस पर्टिकुलर क्वेश्चन आंसर, क्वेश्चन नंबर 25, आंसर इज yx is equal to 0 will have exactly two real roots. Will have exactly two आई बिलीव ये चीज समझ में आई होगी। ठीक है, अब आगे बढ़ते हैं। ओके, सो अब आगे बढ़ते हैं नेक्स्ट क्वेश्चन की तरफ, एंड दिस इज पॉसिबली द लास्ट क्वेश्चन इन डिफरेंशियल इक्वेशन साइड, नॉट पॉसिबली लास्ट क्वेश्चन, अगेन सेकंड लास्ट क्वेश्चन। ओके, ये थोड़ा लेंथी था, थोड़ा सा डिफिकल्ट भी है आई बिलीव एग्जाम के हिसाब से। दिस वाज क्वेश्चन नंबर 25 आज इन योर subjective side, that is NAT 52, sorry, question number 52, question number 52 NAT. So what does it say? It says that y double dash t plus 2y dash t plus k by t is equal to 0, and given that y0 is equal to 0, y1 is equal to 0 and y half is equal to 1 has a solution. So again, this is a easy question, but I think many people would have found it thoda sa difficult, so I'll rate it as a moderate question. पूछा जा रहा है कि what will be the least value of k? What is the least value of k? ठीक है, what is the least value of k for which you have a solution here? Okay, so this is what it is asked. This is what it has been asked in your examination. Okay, this is what it has been asked in your examination. Okay, so let me do the question. So देखिए, इसके लिए डिफरेंशियल इक्वेशन क्या होगी? m स्क्वायर, सॉरी ऑक्सिलरी इक्वेशन क्या होगी? तो गिवन ऑक्सिलरी इक्वेशन विल बी m स्क्वायर प्लस 2m प्लस k इक्वल टू 0. ओके, और अगर इसके पास सोल्यूशन है देन एक बार इसका अपन रूट्स पता कर लेते हैं. सो m1 विल बी इक्वल्स टू माइनस m प्लस माइनस रूट ओवर 1 माइनस ऑफ, सॉरी माइनस 1 प्लस माइनस रूट ओवर 1 माइनस ऑफ k. So correspondingly your solution m1 and m2 will be equals to this, I think एक प्लस मान लीजिए और एक माइनस मान लीजिए. So one is minus 1 plus, another one will be equals to 1 plus root over 1 minus of k. Okay, so your yx will be equals to c1 e की power minus 1 plus root over 1 minus k times t plus c2 e की power minus 1 minus root over 1 minus k times t. So I believe ये चीज समझ में आ रही होगी. This is your solution. अब देखिए आपको करना क्या, व्हाट आर यू सपोज टू डू? यू आर सपोज टू यूज द इनिशियल कंडीशंस, दैट इज यू आर सपोज टू यूज द इनिशियल कंडीशन. नाउ इफ आई यूज इनिशियल कंडीशन y0 is equal to 0, what I'll get c1 is equal to minus c2, या c2 is equal to minus c1. So clearly y0, here is 0, here is 0, you will place equal to 0, that implies c1 plus c2 equal to 0, that implies c2 equal to minus c1. So your yx is equal to what? You are getting c1 exponential, I think minus t also you can take out. So you're getting c1 e की power minus t, and inside you will get e root over 1 minus k times t plus e root over minus. Okay, so this is what you are getting. Okay, so this is your solution. Now आगे की जो कंडीशंस दे रखी हैं उनको भी यूज करना पड़ेगा. So आगे की कंडीशंस क्या दे रखी हैं? Let us assume that if y1 is given to be equal to 0, what does it imply? It implies c1 e की power minus 1 e की power root over 1 minus k times 1 plus e की power minus root over 1 minus k times 1 is equals to 0. अब यहाँ पे तीन पॉसिबिलिटी, e की power minus 1 तो 0 हो नहीं सकता, then this has to be equal to 0 or this has to be equal to 0. But क्या c1 0 हो सकता है? Now if c1 is equal to 0, it implies yx is equal to 0, क्योंकि देखो yx इस पे डिपेंड कर रहा है, c1 पे डिपेंड कर रहा है. For all x belongs to, for all x belongs to, या for all t belongs to, for all t belongs to r. So अगर ये हर t belongs to r के लिए 0 हो जाएगा, then y half has to be equal to 0, but y half is given to be equals to 1. So clearly this will be contradiction, so therefore c1 cannot be equal to 0. अब c1 0 नहीं, इसका मतलब इस पोर्शन को 0 होना पड़ेगा. So this has to be equal to 0. Sorry, this is minus 1. This is in your minus. If you replace c1 by minus c2, so this will be minus. So this is supposed to be equal to 0. If this is supposed to be equal to 0, that implies root over 1 minus k is equal to e की power minus root over 1 minus k. And so therefore what you will get? You will get e की power of 2 times 1 minus k is equal to 1, and 1 you can write e की power iota 2 n pi. So what I have used? I have used the formula cos theta plus iota sin theta is equals to e की power iota theta. And if you replace theta by 2 n pi, so you will get cos 2 n pi is 1, iota sin 2 n pi is 0. So 1 I can write it in a manner e की power iota 2 n pi, where n is belongs to integers. क्या n 0 हो सकता है? अगर n 0 हो गया, if n is equal to 0, it implies root over 1 minus k is equal to 0. That implies k किस बराबर हो जाएगा? 1 के बराबर. So अगर n 0 के बराबर हो गया, in that case k की वैल्यू क्या होनी चाहिए? 1. और अगर k की वैल्यू 1 हो गई, then you can clearly see that your solution will be equals to, well, in that case your yx will be अगर k 1 के बराबर हो गया, in that case, okay, if k is equals to 1, let me first solve it around and then I'll see to it क्या k के 1 के बराबर हो सकता है. So let me initially just place this way. ठीक है, इसका मतलब क्या हो जाएगा? इसका मतलब 1 minus k will be equals to n pi. That implies k will be equals to, I think, root over, sorry. So k will be equals to what? K will be equals to iota, sorry. So k will be equals to what? K will be equals to 1 plus n square into pi square. K will be equals to 1 plus n square into pi square. So k will be equals to 1 plus n square into pi square. Now clearly if I write the solution, yt will be equals to c1 into e to the power minus t, and यहाँ पे क्या था? e root over 1 minus k. So 1 minus k if you do, so what you will get? You will get iota n pi t here minus e to the power minus iota n pi t here as also. Okay. Okay, so what you will get? You will get yt is equal to c e to the power minus t into, if you can see that e to the power iota theta minus e to the power minus iota theta is equal to 2 iota sin theta. If you replace all these things here, so what you will get? You will get c e to the power iota n pi by 2 times of t. Sorry. Okay, so 2 iota sin n pi t. अब यहाँ पे दो इक्वेशंस आपसे देखिए, can n be equal to 0? Now if n is equal to 0, then yt is equal to 0 for all t belongs to R. It implies what? Y half has to be 0, but given that y half is equal to 1, so therefore we arrive at a contradiction. It implies what? It implies n, ठीक है, n क्या, अब n के ऊपर सारी वैल्यूज रखने की कोशिश करते हैं. सो लेट अस नाउ स्टार्ट कीपिंग सम वैल्यूज टू n. नाउ क्या n, sorry, n by t. Okay, now now clearly if I see y half, now let us see that y half is equal to किसका बराबर दे रखा है? 1 के बराबर दे रखा है. It implies c1 e की पावर minus t 2 iota sin of n pi by 2. It implies n cannot belongs to even integers, क्योंकि अगर n even हुआ, in that particular case again कैसा solution मिलेगा आपको? yt is equal to 0. That implies n is supposed to be odd only. That is n is supposed to be 2k plus 1. So n क्या हो सकता है? 1 हो सकता है, 3 हो सकता है, 5 हो सकता है, so on and so forth. So least possible value of n will correspond to the least possible value of k. So k minimum will be equals to 1 plus n square pi square minimum, and n square pi square minimum कब होगा? n equal to 1 के लिए. So you get 1 plus pi square. Pi square is around, I don't know, 9.8 के आसपास होना चाहिए. So this will be around 10.8. So given question will be between range of 10.8 to 10.9. So this was a slightly difficult question, because for me, if I'm solving, I'm using kind of concepts from complex numbers also, although not from complex analysis, but for complex numbers. So possibly this might feel to you as if that it is out of course. I don't know, except this particular thing, that there can be another possible solution. I'll look into it, but for now this is the solution. So answer will be 10.86 or 10.87 around. So this will be between 10.8 to 10.9. Okay. Okay. Okay, so एक और क्वेश्चन जो आपके एग्जाम में है, नाउ दिस इज वेरी इजी क्वेश्चन, बट I don't know, there are two answers to it. How to negate one? I have done it. Let me see. Write in the comment section that I have done it right or not. So question number 48, and this appears to be an easy question, but again in examination probably this will become a moderate question, because in exam condition you are bound to get confused. See, now as of now when I'm recording it, I know the answers to it. I know, so only part for me is to generate solution to the answers given. Okay, so that happens to be an easy task for me. But for a student who's writing an examination in those exam stipulated conditions, this particular easy question also appears to be moderately difficult question. Why? Because in this particular question, there are two answers to a function at point x equal to 2 that was asked in the examination. So to negate one, what could have been done? I'll do one thing. Probably you are there to judge me, and you can always write it in the comment section that you are following it or not. Okay, let us start. So given question was to find the solution of this particular thing. So d 2x plus y dy upon dx plus x minus 2y equal to 0. So this was asked possibly in your examination. So I believe isko kaise karna tha. Sorry, I believe this is x minus 2y or something. Just give me a minute. I believe this is the question. So we had to solve, I think this was a question, x minus 2y dy by dx plus 2x plus y equal to 0 with given conditions that y1 was given to be equal to 1. So there are two possible ways. One way can be to make it a homogeneous differential equation. I don't like that way because that is a longer way. So better you can do it by using exact forms. So solution. So clearly x minus 2y dy plus 2x plus y dx will be equals to 0. So your m is equal to 2x plus y. Your n happens to be x minus 2y. So my is equals to 1. Nx happens to be 1. That implies your equation is exact. So whenever your equation is exact, what you can do, you can simply integrate m with respect to x, keeping y constant. So this is a shortcut rule that I'm using, and you can integrate n with respect to y, all those terms which are free from x, and you can equate it to some constant, let's say c1. So what you are going to get m dx, when you are integrating, you are getting x squared by 2 minus 2xy. I think it is, sorry, m dx plus, sorry, so x minus 2y dy. Okay, sorry. So this is, I think you can integrate it, sorry, you can integrate it on yourself. So what I believe will get as x square plus xy, and free from y you will get minus, free from x will get minus x square is equal to c1. Now at x equal to 1, you're getting y is equal to 1. So what you're getting c1 is equal to 1. Okay, so your given solution is x square plus xy minus y square is equal to 1. So I can write it in this fashion. Okay, so this is your solution. Now what is asked that at x equal to 2, y की क्या value होनी चाहिए पहली चीज, and know that y is defined from 9 by 10, 3 to r. So it is given that y is a differential function defined from 9 by 10, 3 to r, which is satisfying this particular differential equation. This is given in the question itself. So at x equal to 2, what is the value of y? It is being asked in the question. So you just replace here. So this is 4 plus 2y minus y square minus 1 equal to 0. So you're getting minus y square plus 2y plus 3 equal to 0. So what you're getting y is equal to 3 or y is equal to minus 1. So you're getting y is equal to 3 and y is equal to minus 1. Now from this you can only have one answer. From this you can only have one answer. Let's say y2 is equal to minus 1 and y1 is given to be equals to 1. Since yx is differentiable, अगर differentiable है, it implies yx is continuous. और अगर yx continuous है, so by intermediate value theorem, intermediate value property, there exists some x naught belongs to 1, 2 such that y of x naught will be equal to what? 0. आप खुद देख सकते हैं क्योंकि देखिए y2 पे -1 है और y1 पे 1 है, so at 1 y is positive, at 2 y is negative, so there exists some x naught such that y of x naught will be equal to 0 by intermediate value property. That implies मान लेते हैं वो x नॉट है जहाँ पे y क्या है 0 के बराबर. So that implies at x naught you are bound to have y as 0. So you are having x naught का square plus x naught into y of x naught minus y of x naught का whole square minus 1 equal to 0. Y of x naught will be 0. This will be 0. It implies x naught will be equals to plus minus 1. So या तो x naught plus 1 होना चाहिए या फिर x naught क्या होना चाहिए minus 1. X naught cannot be equals to minus 1 since the domain of the function is defined from 9 by 10 comma 3. Now if x naught is 1, if y of x naught is equal to 1, y of x naught is equal to 1, sorry, if x naught is 1, so if x naught is 1, then y of 1 is equal to 0. ये तो हुआ, मतलब हम ये कह रहे हैं कि x naught की वो वैल्यूज है y क्या हो 0, that implies y is equal to 1, but y1 किसके बराबर दे रखा है 1 के बराबर दे रखा है. So you arrive at a contradiction because अगर ऐसा हुआ then your function cannot be defined, that is at 1 you cannot have two images. So according to given IVP, since y1 is given to be equal to 1, so y1 cannot be equals to 0. So therefore there exists no such x naught. It implies y2 cannot be equals to minus 1. So y2 has to be equals to 3. So this is the explanation from my side. I believe you're free and open to criticism and your suggestions. So kindly give your suggestions, kindly review us. Thank you.